This is our AB92 solution in the ionized water. So this is now thoroughly, or you can say well mixed. Now our next task is to first of all do the wavelength scan, and here, as you saw in our old videos, we have to change the wavelength. So I will keep here 400 and then I will change here to now for analysis. I usually prefer glass cuvettes for the dyes, and for the organics I prefer quartz cuvette because the dyes stick on the surface of the quartz cuvette and it's difficult to clean. So now we'll say 0. You see that in water there is no peak, so I have added this higher concentration for scanning. We'll say read. We have calculated the lower stock from the from the higher stock using the serial dilution concept, or you can say the quantifications. So already we have seen these concepts in our old videos, how we prepare from the higher stock to the lower stock. So here already I have shown you that this is my higher stock. So for my higher stock I have went down to 1, 5, 10, 20 and also I made 0.5 ppm also. So 0.5 till 120 ppm. Now here the peak, if you see, the peak is around, if I keep toggling or scrolling, so you see so this is my maximum peak, maximum lambda. So based on the maximum lambda, see this, okay, so this is my lambda max, which is around 570 nanometers. Now based on this I will choose user program and I will say program options and I will say new, and then we can give a program number, okay, and then user program, for example I would say A, B, then 92, next. This is single multi, so I will say single, next, and then the concentration is milligram, gram, microgram. You can make your concentrations different calibration. We added the values here, and then we will start from the ionized water. I would say 0, then read, and then subsequently we will start from 0.5. So 0.5 shows 0.021, shows 0.039, which is double of 0.5, shows 0.22, shows double of 5, 0.454, and 20 shows 0.908, shows 1.779, shows 3.455, 3.679, 20 shows 3.862. We have a lot of points in the calibration curve. So let's go next and then see some of the points are going out of the line, so we'll go back and check. Okay, so this is double, this is also okay, this is also okay, this is also okay. Okay, so suppose you can go ahead and check. So some of the lines like 120, this is starting from 5, 0.5, 1, 10, 20, and this is 40. So we need to delete some lines, some points. Suppose we delete this, still there is some point that needs to be deleted. Sample, okay, Since we deleted some points, so you can see now the fit is very okay, which is 0.9934. So even you can see the next curves. Okay, so this is the equation. Okay, now we'll say done, and then we can say store. So this is your wavelength, resolution, chemical form, calibration. Okay, then we will say store, then we will exit and then try to start and try to read the unknown values. Again you will press 0, and this is your unknown, which is showing 3.522. And now our range is sticking to, I think, till 100 ppm. So if you are measuring 200 or 120 or 140, so in that case you have to dilute your samples to some specific level. So whatever values you will get, you will multiply the number by the dilution factor. Okay, so this is all about the calibration of acid blue 92, which is an anionic dye by the UV visible spectrophotometer.